This is class A. Briefly, subnetting is the process of dividing a network into smaller, more manageable subnetwork or subnet. Each class of IP address has a default subnet mask that defines the number of hosts and network available. You see, this is class A. Now, with class A, this basic, guys, please, the range for this class A is from 1 to 126. That's the range for class A. The default subnet max for class A is what? 255.0.0.0/8. You see? So this /8 mean these 8 bits, these 255, they are all on. This /8 represent these 255. It represents that these 255, they are all on. They are all 1111, 8 ones. These are all off. The zeros are all off. So with the class A, which range from 1 to 126, and the default subnet max is 255.0.0.0. Inside that, if you don't want to type this 255, you can just say /8. When someone says /8, take note, he's referring it to this. So now, number of hosts per network. If you are implementing now class A, you want to do class A subnetting, take note that within an open network, this is the amount of IP address you get within a network. For any network in class A, you have 16,777,214. By default, it's 216, but minus 2, it gives us 214. So you see, this 2 to the power 24 will give you what? 2 to the power 24 will give you 16,777,216. This is the IP address you already have at hand that you can able to deploy within a premises, within a network. So that's why this class A is being used by a large network, data enterprises, big service providers. Small enterprise don't use this class A. Now we move to class B. The ranges of class B. Class B range from 128 to 191. Now the default for class B is, the default subnet mask is 255.0.0. SADA notation is /16. So you can see the class A the class B range from 128 to 191. The default subnet max, because when you start to do subnets now, you first need to know the defaults before you can subnet. So you already know the default subnet max for class B is 255.255.0.0/16. This /16 represents the same thing, meaning this 8-bit is on plus another 8-bit is on. If you add the 8 plus 8, it gives you 16 bits. Now within a class B, if you are implementing class B to a particular network, it will give you 65,534 IP address that you can able to assign to end devices if you are implementing class B. That's why class B, medium enterprises use class B. 2 to the power 16 will give you what? 2 to the power 16 will give you 65,534 IP address. Why do we get this 16? This 16, you can see it here. These 2 octets, they are all on. But totally, the total is 65,536, but minus 2 give you this total. Now we move to class C. Class C range, the range for class C is from 192 to 223. This is the range for class C. The default subnet max for class C is 255.255.255.0. This is the default subnet mask for class C. You can see /24 with the cider, meaning this 8-bit is on, this other 8-bit is on, and this 8-bit is on. If you add 8, 8, 8 will give you 24. Inside that, you can just say /24, meaning the engineer or the technician will know that /24 means he or she need to implement this subnet mask to the PC after assigning the IP address. Within this class C, the number of hosts you will get if you are implementing the class C, you will have at hand 254 valid IP address you can allocate to your end devices. 2 to the power 8 will give you 256 minus 2 is what? 254. Now, proper subnetting. Now we want to do subnetting using class C. I want us to start it from class C. We go to class B and class A. Because class C is a small network, so you will have the momentum. You can build the momentum while we are going from C, B, and A, which have large networks. So now, always bear in mind when doing your subnetting, the power of 2 to the power 1, you need to understand that when you say 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. You need to be aware of these powers, 2 to the powers, and at the same time know how this bit table operates. The power of 2 and the bit table. Subnetting. The main tools that I want you to have at your hand, in your belt. Know your 2 to the power. When you say 2 to the power 1, you know exactly what it means. When you say 2 to the power 2, you know exactly what it means. When you say 2 to the power 3, you know exactly. Now, when you say the bits table, you can able to write down this table, which range from 1 to 128, or from 128 to 1. Now, subnetting class C. Example 1 says, let's subnet 192.168.1.0. This, by default, the given IP address is this, and the subnet. The given IP address is this. I think let me zoom this for you guys to see it. Okay. So now you can see, you see the subnet here is, this is the subnet given 192.168.1.0. But with this subnet now, they want you to subnet this to /26. They want you to subnet it to /26. Why? Meaning, if we are subnetting this to /26, they say the network is 192.168.1.0. This is our network. This is the IP address network you have at your hand. Now the default subnet max is what? 255.255.0. You can see it. This last 24 indicate this subnet max. This is our default subnet max. Now they say our new subnet max now is 255.255.255.192. How? We will find out. Now the subnet of the number of subnets within this network they give us is what? They say it is 4 subnets. We will find out. The number of hosts within, if we use /26, it will give us 62 hosts. So now let's do the subnetting to arrive at 62, to have 4 networks, to have this type of subnet max. Arrive at 4 network, have 62 IP address and to arrive at this subnet mask. Now if you want to subnet this IP address, which is 192.168.1.0/24, which is given unto you, now your boss says subnet it with /26. The first thing we need to do, we need to convert what? This our subnet, this our default. This is our default subnet mask given on story to us. So now you need to convert this default to what? To binary number. If you didn't watch the previous session on binary, how to convert from decimal to binary, please make sure that you watch it. Now we need to convert this to binary. This first octet class, this first octet is how many bits? Anyone? How many bits is this first octet?
8 bits.
8 bits. So now if this first octet is 8 bits, now let's type this noun. We can see this, it is 255, meaning is this on or off? All these bits, are they on or off? The 8 bits, are they on or off? Anyone?
They are on.
They are on. You see, because as you see this 255, meaning they are on, and they say 8 bits. Now we say if the bit is on, we say 1, 1, 2, 3, 4, 5, 6, 7, 8. We make our period. Now we have convert this 255 to binary. The binary for this 255 is 8 bits all on. So we move to our second binary number, our second octet. This is the second octet. Now we already know that these 255, they are all on, and it is 8 bits. Now we said 1, 2, 3, 4, 5, 6, 7, 8. We type our period. Now this the third octet. This third octet is 255. We already know it is 8 bits, and all these 8 bits are on. We said 1, 2, 3, 4, 5, 6, 7, 8. We type our period. Now we can see this 0 here. The 0, how many bits is representing this 0? How many bits is representing this 0?
8.
8. Still 8 bits.
It's still 8 bits. It
They are
doesn't
8
matter.
bits.
Yes, it is 8 bits. It doesn't matter because it is 0. It still represents 8 bits. Now these 8 bits, are they on or off?
Off.
Off.
These
Off.
8 bits,
Off,
they
sir.
are all fine. They are all off. So if the 8 bits are all off, we type 1, 2, 3, 4, 5, 6, 7, 8. This is the first step you need to understand about subnetting. This is the first step. Now you have this IP address. We are subnetting this IP address to what? To from /24 to /26. So if we are subnetting this /24 to /26, how many? Now you can now see 24, 25, 26. The new subnet, they say us to subnet to change it to 26. So if we are subnetting this now, 26 means now this is 8, 16, 24. All these ones are 24, meaning this 0 have moved to one subnet, this other 0 have moved to the same subnet. Now these 2 zeros, meaning if we convert, we need to convert these 2 zeros to 1, so we can have 26. Take note, you are converting this, subnetting this to /26, but you already have 24. So after writing this, now you need to change this from 0 to 1. We have 25. We change this also from 0 to another one, 26. Now if we check now, our default was 24, but they say for us to convert it to slash 26, now we have 26. 8, 8, 16, another 8 here, 24, plus 2, 25, 26. Guys, this first step, do you guys grab this first step?
Yes, sir. We are moving. We are moving.
Fine.
We are making progress, sir.
Perfect. So you see, you only and this class C, a lot of IT technicians will implement class C. That's why I'm taking my time, please. You can see this. You have your network given onto you, but it is for you to convert it to slash 26. Now, your first step, you convert the subnet max to slash 24, which is default. This is your default. You convert it to binary. After converting it to binary, now you look now, how many bits do I need to add? How many bits do I need to change here? The new bits change here is 2. Now you have changed 2 because you have removed the 24, which is, these are the 24 bits. After converting, now you have add 2 new bits, which is now 26. Now from here on, your next subnet, you need to look out now for block size. When doing your block size now, you need to consult this table. You see? Now you are your next step. Phase 1, you have convert from binary from decimal to binary using your default subnet max. Now you already have your new subnet max, which is slash 26 converted here. So now your next step is you need to find out your block size, because with this block size you use the block size to do your subnetting. Now what will happen? This you are seeing here, these 2 bits that are on, we need to tally these bits. These are 8 bits. You can take this for simple term. For simple term, we can say these bits, these are 8 bits, this is your 8-bit table. You place 1. This is your last octet. Your last octet here. Not forget about all these ones. Your last octet here. Now we say 1 8. This is the one. This is the other one. This is 0. 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 You can see. Now, this last octet, we have tallied this last octet under the bits, the 8 bits. To find our block size is the least number that is on. The number that is on, the least IP number that is on after converting. This, if you can see this, guys, just 1 minute. Let me connect my Wi-Fi to my power bank. Lights just went off before this thing. Just a minute. Where's my power bank? Okay. Okay. So now you can see we have tallied the one under this IP address. So now to find out our block size now, the block size, they say where the last one, this is 1, this is another one, the last one where it stop here. If this last one stop here, meaning this is our block size. You see, the last one, if this one was here, this 0 you are seeing is 1, meaning this will be our block size. But because this is the last one here, this is our block size. So this block size, you are going to use this block size to increment to do your subnetting for this particular network given unto you. Now let's say what? Take note, this is our block size 64. But when you are doing your subnetting now, the other thing you need to be aware of. Now with the subnetting now, this is your parent network. This parent network, you need to maintain your parent network. Now I want to do the subnet. Let me try to enlarge this so you can see this work. Okay. Okay, so now this parent network you are seeing here, you need to bring down the parent network. This is the parent network down here. You see, this is the parent network. Now, after writing down this parent network, you need to increment what? Increment this block size, this 64. This is your block size. Yeah, this is your subnet block size now. Now, the next thing you need to do, you need to say 192.168.1.64. Now you need to increment this 64 also to another subnet. 64 plus 64, it gives us 128. You see, now if we increment this, so you can continue to add this 64 up to 4 network. You can get 4 network. But because of I don't want to waste a lot of time, I just stop it at this 3 network. So now see, this is our parent network. This is the parent network given us to us. Now we use our block size. This is our block size. After converting our subnet max, this is our block size. Now we increment 192.168.1.0. This is our first network. The second network is 192.168.1.64. This is our second network after incrementing. Now our third network is 192.168.1.128. So the fourth network is 192.168.1.196. You see, it's increment 64. You are now subnetting this. Now you have done your subnet. Now for this network, and this network. Now you have already created 3 networks within this. With just this network, you now have 3 networks. You can even go to 4 more networks to get 4. You can add 1 more network to get 4 networks. You see? Now, what will happen? Instead of you now wasting that 254 IP address, now for every department now, we'll only have 62 IP address instead of wasting 254 for every department. So now how you find out? To know the IP ranges. Now for you to know the IP ranges between every department, Department A, Department B, Department C, after doing this subnet, for you to know the ranges between this network, what will happen? This is your first network, right? You have write down your first network. Now you have subnet this to your to your second network. This is your third network. Now you need to take this, your second network, move it up here. But when you move this second network above here, you see some changes. This 4 changed now here to 3. You can now see 8 minus 1. Now you are moving your network up. When you move it up now, you say minus 1 here. Now the second phase, you have already write this second network. What will happen? The third network, you move this third network up. But when you want to move this third network up, what will happen? You can now see that you maintain everything, but you say minus 1. If you move this up, your last octet, you say minus 1. Now if you see, the last octet now is 192.168.1.127. Now you have -1 from this last octet. You see, if we go up one, now if we add one more subnet to this, 192, that one more subnet to get this 191 is 192.168.1.192. Because if you add 64 plus this 64 on this 128, it will give you 192. If you add 64 to 128, it will give you 192. So 192 minus 1, that's why you are seeing this 191 here. Now you already know how to subnet A. We have already subnet this to 3 network. Now we want to know the range between. Now here, this is the slide now. Now we want to know the network address now for what we have done. The network address for this is the network. Your first network, this is your first network. We can take this first network now. See what? When you come here, say the first network now. This is your first network on paper. Now they say the first usable IP address. The first usable IP address for this network now. The first usable IP address for this network now is 192.168.1.1, because after 0 you get 1. You see? Because 0 is the network. Now our first usable IP address for this network now is .1. Our first usable IP address for this network, not all this network, just this network now. Just we are analyzing just this network. You see? So now our last usable IP address on this network I highlighted will be what? Will now be 192.168.1.62. You see here, this here now we say minus 1 also here. You see? Now you can now see this, the last here is 63. But this 63 here is not usable. You can't use this 63 in our network. Why? Because this 63 is the broadcast IP address for this particular network we have created. This 63 communicates within this network, telling the IP address that we are all within this broadcast domain. 63 here. So you cannot implement this 63 in any device. It's a broadcast. We'll keep it. It's a reserve. The last usable IP address for this network now, it starts from .1 to 62. So now the IP range for this network, the IP range now for this network is from 1 now to 62. From 1, the IP range now for this network, it ranges now from 1 to 62. As you can see, this is the network. Our first usable IP address is 192.168.1.1. Our last usable IP address is 192.168.1.2. Now the IP range now is what? From 1 to 62. The broadcast IP address now. The broadcast IP address now for this network is this. The last IP address, which is not usable. You see, this is the last usable IP address now, and this is the broadcast IP address now. This broadcast IP address, we don't use it. We don't implement it in any network. Fine. This is our network. The network. This is the network, which is here, the IP address network. The first usable IP address within this network now is .1, which is this .1, and the last usable IP address is 192.168.1.62. The broadcast is 63. So now, let's say, now we want to find the network for the second for the second subnet, the first usable IP address, the last usable IP address, the IP range, and the broadcast for the second network. For the second network now, what will happen? So now, what I want you to do, see this. So, guys, so now see this. So this second network we are seeing here. This second network now we are seeing here. So now this is the network you are seeing. 192.168.1.64 is the network. So what is the first usable IP address now for this network? Anyone can try?
Yeah, sure. I can try.
Okay. The first usable IP address now for this particular network is what?
It has to be 192.168.1.60. This is 64. This is
The first usable IP
65.
address. 65. Perfect.
65. Yeah.
Yes, perfect. So you see now the first usable IP address now for this is 65. This is the first usable IP address. This one up here is a network now on its own. You can assign those IP address to, let's say you have department A, B, C. Department A, you cannot assign the IP within these ranges. So now the other departments now, their own IP address starts with .65. .65. So now, the last usable IP address for this network now is what? The last usable IP address for this network could be what? For this network, yeah.
The last usable IP is 192.168.1.126. Remove the broadcast.
Perfect.
Yes.
Perfect. So you see, you remove the one now here. We can now see. See, the last usable IP address now within this range now is 126. The valid IP range between for this network now is what? Who can tell me? The valid IP range now is, it's range now from where to what? For this now, the valid IP address
Still,
we can it now range from where?
It goes on 65 to 126.
To 126. You see? Now we can now see that within this network now, let's say this is A, department A, this is department B, this is department C. Fine. So you see, within this department B now, you want to know the valid IP address range that you need to assign to that particular department. It will start from 65 to 126. Now the broadcast IP address. Who can help me with the broadcast IP address? The broadcast IP address now for this particular network.
I say 192.168.1.127.
One, perfect. So you see, now this is now our broadcast. So for this broadcast IP address, you will not assign it to any PC within your network. When PCs want to talk within the same domain, this broadcast address tells them that we are all in the same domain network. This is broadcast. They communicate through this broadcast address. You can't assign it to any PC. So now you can now see DEPART. Oh man, I don't want people to be confused. One, please guys, a minute. Let me. Okay. I think this one will be cool. Let people don't confuse this ABC to another ABC. So now, let me just paste this. Perfect. So now we now know that within this network, our IP range from 65 to 126, which we can assign to our PCs. Now we move to the other network. Within this network, you just after the hardest part is for you to do the subnetting. After doing those subnets, converting from binary from that decimal to binary, use your default subnet max, add to that your new subnet max you now have, then you can increment. Now we say this is department C. Department C network is 192.168.1.128. This is the network. This is your network. So now, what will be our first valid IP address here? Our first valid IP address for this department, department C.
Okay, that is 192.168. I no longer see your screen.
Okay. Are you seeing it now?
Okay, 192.168 1.129.
129. See? Now the first usable IP address now is this is now our first usable IP address. So the last usable IP address, anyone? The last usable IP address.
Okay, 192.168.1.190.
190. So you see, so now our last usable IP address is, this is now our last usable IP address. So now the IP range now is what? The IP range. One, 2, 9 to 190. The broadcast
190,
now is perfect. While the broadcast is now 191. So you see, the broadcast is now 192.168.1.191. This last IP address. So you see, now take note, because you are now implementing the other thing you need to be aware of. Now, because you are now implementing /26, you are now implementing slash 26, what will happen? Your subnet max have changed. If you are implementing now the subnet max in these PCs, you are no longer implementing this 255.255.0, but now you implement 255.255.192. Why this 192? The 192 is that now this our two borrowed IP two borrowed bits. If you add these two bits you are seeing here after doing our conversion, this is the 2 bits that are on now. If we add these 2 bits that we borrowed, 128 plus 64 will give you 192. You see? So now when implementing your subnet max now to the PC, after assign, let's say for an example, you have assigned this 192.168.1.128, what will happen? The subnet max now, you implement 192.168.255.255.192 to that particular PC as the subnet max, because you are done subnetting for that particular network. So we fast forward to example 2. So example 2 now says 192.168.1.0/24/2/28. /28. Let's convert this using /28. The first says /26. This is now /28. So with /28, the first thing what we need to do, we convert this our default subnet max. You convert. Now we now already know 1, 2, 3, 4, 5, 6, 7, 8. All these bits are on. We said 1, 2, 3, 4, 5, 6, 7, 8. All these bits are on. 1, 2, 3, 4, 5, 6, 7, 8. All these bits are on. Now, if we type just the defaults, say 1, 2, 3, 4, 5, 6, 7, 8. This default, we have converted this default to binary. Now, they tell us now this default need to change from this /28 to this /24 to /28, because we are now subnetting using /28. Why? Because that particular department, you see, if you use /28 now, the total host you will get is only 14 hosts. You see, like if you use /28, that every department is supposed to have at least 14 hosts. More than 14 hosts, no way, or below 14 hosts. That's why subnetting is very, very good. So now we want to convert to /28. We already have 24. Then this 1111 is this that we have converted. This other 111, it is this we have converted, and this other 111, it is this that we have converted. This 0, it is this. That's why it is the default. We have converted the default subnet max. Now we say that we need to subnet for /28. Now this first one become 20, because we already have 24. 25, we change this 0 to 1. 26, we change this other 0 to 1. 27, we change another 0 to 1. 28. You see, we have borrowed 4 bits here from these zeros and convert them to 111. So if we add now all this 111, if we convert them now to decimal, this is 255 slash what? 28. 28, 8, 8, 24, 25, 26, 27, 28. Your next step is to consult what? To check your bit table. You now need, if we take now this one here, we put it under this one. We take this other one, we put it under this 64, this one under this 32, and this one under the 16. All these other zeros represent these 4 zeros. You see, because of time. So now, if we put all this 1 under here, the last bit that represents 1 here is 16. So this 16 is our block size. You see? Now we have taken this after converting, we tally these ones under these numbers. This last one here you are seeing, this last one, it is under this 16. Because this last bit is under this 16, the last bit is under the 16, or the last bit, when the last bit is under any number, that particular number is your block size. If this last bit was under 8 or under 4 or under 2, that particular number will be our block size. But because after tallying 1 1 1 1 4 ones, 1 1 1 1 4 ones, the last one is 16. This is our block size. So now we subnet. But after when doing subnet, what do you say? You maintain your parent network. With this parent network, what? We say what? Our first subnet here is the parent network. Now we increment our block size. The first block size is 16. The second 16 plus 16 is 32. You see? You are incrementing the 16. You first parent, you maintain, you add 16 plus to the 0. Now, if you add another 16, it will give you what? 32. If you add another 16, it will give you what? 48. You see? You are incrementing your block size. Now, we have incremented the block size to 3 network. Now, our next is to range. You move now. That's why you have your pen and paper, even during your exam. Pen, paper, you write them. You move this network now. When you move it up, it is minus 1. Now it represents here now 15, minus 1. You see? Now we are moving this 32 up. It is now minus 1. 192.168.1.31. You see? Now you can see this. If we add other 16 to this 32, it will give us 48. So with 48 now minus 1, it gives us this 47. So now our first usable IP address within this network. Now all you know, this is our network, right? First one. So the first usable IP address now for this is what? For this network is what? Anyone?
192.168.1.1.
Perfect. So we go. So now we now know that the first usable IP address now for this network is .1, and the last usable IP address is what? The last usable IP address for this network.
.14.
.14. You see? Now the IP range for this network now is what? The IP range now for this network is what?
It's 1 to 14.
See? Perfect. Now it's 1 to 14. So now you can now see. Now the broadcast address now for this network is what?
Oh, say 1 to 15.
So you see, the broadcast address now is 1.15. This is the broadcast. So you see, you have subnets this 192.168.1.0 from 24 to 28. Now you have subnugget this, just this network. You have nugget it to sub networks. Now these sub networks, if you can see, they say it ranges from 1 to 14, meaning you only have 14 IP address you can allocate within this network here if you are implementing it. Here also you only have 14 IP address. Here also you only have 14 IP address. You see, you can implement these IP addresses within everywhere. You can replicate the same thing here. We already know now. Here our first usable IP address now is 192.168.1.17. Our last usable IP address is .30, Our broadcast IP address is now is .31. You see? So now the last usable the IP range now for this network is from 17 now to 30, because this is your network. 16 now, the first usable IP address is 17. So here now 192.168.1.32, the first usable IP address now for this network is what? Anyone?
One dot 33.
33. So you see, I know that you guys have grabbed this concept now. So I don't just want to keep on repeating this stuff. So we'll move faster. So now this is class B network. With class B network now, the things you need to know. Class B now, we implement class B network within medium companies, medium businesses, not small but medium-sized businesses, because it can give you 65,534 IP in every network you create. So now the given exercise here is this subnet 172.16.0.0. If you can recall from our previous session, when we talk of private IP address when implementing class B, you see this is now 172.16.0.0, which range from 172.16.31.0.0. So now with this, we are implementing now 172.16.0.0/16. This is /16 to into what? /18. /18. Now they say the default. Take note here. The default subnet max is what? 255.255.0.0, and we need to convert this default subnet max to binary. So now we already know these are all ones. When you see 255, they represent 1. They represent what? They represent 1, 2, 3, 4, 5, 6, 7, 8. This other 255 here, it represents 1, 2, 3, 4, 5, 6, 7, 8. Now this other, you can see this other 2D octet. They both represent 8, which is 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you see, you convert. Please, my guys, during your exam, please don't forget, just convert. Patient, though you do a lot of fast, but make sure that you convert. When you need to this, you convert. Now, how many bits do we need to borrow? This is 16, 17, 18. How many bits do we need to borrow now? Anyone know how many bits? Now we need to borrow 2 bits. How? You can see this is 16. 16 down to 18, meaning 16, 17, 18. You just count 16, 17, 18. So now these 2 need to convert to on. So if we convert these 2 to on, what will happen now? Now we now have new subnet max. Our new subnet max now will move to, you can see from here now, because we are subnetting now for /18, what will happen? We shout for our block size. Don't get confused, because this is class B. You see this 111, this 111. You take this same digit here. You take this same digit, you align them to your bit table. The last bit that is on here is what? Is 64. This last bit, you can see. You see this last bit here. If you tally this one here, forget about these ones that are on here. You are working with the digits that you borrow, that you convert to 1. This is 16, 17, 18. You have convert 2 zeros to 1, 1. So if you tally them, this one here too, and this other one is 64. So your block size now is 64. You see, but when you want to do the subnetting, you maintain your parent network. Now you can see the parent network down here. This is the parent network. Now we are subnetting on the what? Third octet. In class C, we are subnetting in the fourth octet, but in class B now we are subnetting in the third octet. You see, this is the first. You already know octet. This is the first octet, second octet, third octet. We are doing our subnet under the third octet now, so you can see. Yeah, our second network now is 172.16.64.0. You see, the first one is 172.16.0.0, which is this, giving us to us. Now we maintain it. Now based on our block size here, our next phase is 64.0. You see, with class B now, we didn't do nothing with this bit, this last bit here. We didn't do nothing with this last bit, so you have nothing to change with that last bit. You maintain it. You work with this third octet, first octet, second octet, third octet. You can see first octet, second octet, and the third octet. So the block size now increment to 64. 64. Our next block size for 64 is what? 128. You see, because we are incrementing. Now we move these networks. If you move around, because you want to know the ranges, for this particular network, you now need to move this network up. After moving the network up, what happened? Now you say 172.16.63 as usual. The minus, then the last octet now represents 255 because you have done nothing with that particular network. So you convert it to decimal, which is 255. Now our next subnet is 128. 172.16.128. How? 64 plus 64. It gives you 128.0. When we move it up, you can see minus 1. It gives us this. Same thing, we increment. So now, here guys, I want to know, this is class B. Our first network IP address is now what? This is our network. Today I really want us to, let's just done our subnet. We'll start to do some configuration now. So now we say what? Our first subnet, our first valid IP address now for this network now is what? Anyone? Guys, are you getting me? It's the same thing. You don't Okay. Now, this is class B. Yes, I can understand. But it is the same thing. You can now see here. From here, because we are now assigning IP address, our first subnet max now maintain, you see, it is .1. You see? This 0 is our network, and the first IP address for this particular class B, it is still 172.16.0.1. Our last valid IP address here, we said it is what? It is within this 62 62 dot what 255. You see, I know maybe you are a little bit confused. Yes. So now, what I want you, the concept you need to grab. You see, when we work with class C, we are using the fourth octet. But with class B now, we are using the third octet. We increment using the third octet. For you to see, you see class B, this 111 is on, this 111 is on, but we have 2111 in the third octet here. You already know every 111 represents here one octet, other octet, and other octet. But this last one here, we didn't use it. We have nothing to do because we only borrow 2 bits from the third octet. That's why if you can see the subnetting here, our 64 fall under the third octet. First octet, which is this, second octet is 16, and the third octet, which is our block size, is 64. We move this up now, which is 63. So now if we watch now, our first IP address range will not change. 16.0, this is our first network, which is now the last IP now here, it is what? 62. Because we are working with the third octet. You have nothing to do with this last octet. You have nothing to do with the last octet because you operate on the third octet. So this is now 62. These are all bits that we'll be using. And if you minus 62 from this, so you see you have lots octet. You have what? 16. Now our valid host for this range, for every range here, is 16,382. The valid range between this to this, it will give us 16,382 hosts just between these 2 IP addresses. While you already know the total is 65,000. You understand? So please don't get confused. So now our first IP address is this. Our last usable IP address you maintain. Don't take your eye off your third octet. Don't take your eye off. Our third octet here is 62 now, because this is 63. Now we said our IP range. This now range from 1 to what? One to 62.
They don't just like it's still going to vanish in your eye.
To 62.255. See, our IP now range from 1 to 62.255. So meaning we have more other IP address behind that we need to change. We have a lot IP address that we need to manipulate. We need to change because this last one here to 254. Okay, this last one here we didn't use it. The last digit we didn't use it. So when it comes to assigning IP addresses, you can assign up to 16,382 IP addresses. So more digits are behind that we didn't use. So you need to be aware that now
The last usable IP should be 254, not
Yes.
255.
Yes, it is 255, the 254. Have you seen it? The usable now is what here? 254. 62.254 here. So I just forgot about the digits, the other 2 digits in front. For us not to waste too much of time. So now, they say the broadcast noun here. The broadcast noun is, who can now tell me the broadcast for this network? For this network. The broadcast is now 172.16. What? 63.255. You see? Take notes. This is your last IP that you are not using, but your usable valid one is 62. Now the broadcast, the 255 here represent a broadcast, because within here we still have what, 254 bits that are on, up and running. These are all usable IP addresses. So we move to, I think, let me see the time. Okay, so now same thing, class B example 2. Class B example 2 now, they say we are now working with what? Slash from 16 to what? To slash 20. 16 to slash 20. What will now happen? 16 to slash 20 now, this is your default. Pretty easy. If you can convert this default to binomial, now you can able to understand, you know your block size. From your block size, you can able to increment. This is the method. Convert your subnet max, look for your block size, increment the block size. These are the steps. So now, if we convert, well, you know, if we convert, now this subnet max here, it will give us 1, 2, 3, 4, 5, 8, 8. See. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you see, we have converted this subnet max to slash 16. So the next question is, how many bits do we need to borrow? So now 16 said we need to convert it to what? 20. So to reach slash 20, meaning we need to convert 4 more bits. So if we convert these 4 more bits now, we say this 0 convert to bit, this 0 convert to bit, this 0 convert to bit, and this other 0 convert to bit. So you see, now we have convert these zeros to bits. Now we have 8 bits. These are 8 bits, another 8 bits plus other 4 bits. 16 plus 4, it gives us 20. Now we have convert now this subnet max to the recent, to the new subnet max. So now the new subnet max now will be 255.240. But from here now, you need to know your block size. You take this same 111, you challenge them under. You see, if you can challenge 111 4 ones, 1 1 1 1 1. So now our block size is what? Quick one. Guys, our block size now is what for this 16? We have taken this 1 1 1 forward, we have placed them under this 128, 64, 32, and 16. So what will be our block size? The block size now will be, if you take this 111, the block size now will be 16. You see? Now this one is under this one is under this one is under this 32, and this one is under this 16. So now the block size now is 16. So if we increment, we need to use now this 16 to increment. And we increment in our 19 is 0, 16 and 32. What happened? Now you can now see, you move 16 to up here, minus 15, 32 minus 1 is 31. It's the same thing, you will repeat the same pattern. Now we now know that the blocks, the first object now will be here is what? the first octet now, the first valid IP address now will be .1. Our last IP address for this network okay, this is our network. The first now will be this, which is .1, and the last usable IP address here now will be, we say what, 14 dot 254. Now the IP range here now will be 1 to 14 dot 254. So you see our broadcast now will be .255. So this is it. So now class A, we move to class A, which is the last subnet for today. Then I'll give you assignments slide for you guys to do it. To do the slide, please make sure that you do the assignments and submit. That will there's rewards for all those things. So now the class A. The class A is the same thing. This is the /28. With /28 now, we already know 10.0.0.0/8. You see, only 8-bit is on. That's why we are seeing this /8. Now with this /8 now, if we subnet with 8 from /8 to 12, now we need to borrow how many bits? 8, 9, 10, 11, 12. 12. So now, the first thing you need to do to subnet to 12 network using /12 subnet, what you convert this. We are converting this network, this default subnet max to what? This is pretty easy. Same thing. 1, 2, 3, 4, 5, 6, 7, 8. Dot all the rest now, they are all 0, 0, 0. 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. So you see, you have converted this. So now, if we are yearning for the subnet, now we need to borrow how many bits? 4 bits, because from 8, 9, 10, 11, 12. So we convert this to bit, convert this to bit, convert this to bit, convert this to bit. So you see, so we are convert now this to bit. Now our next step is our block size. If we tally now 8, 9, 10, 11, 12, our next, you tally this 1, 1, 1, 1 under this, our next block size is what? It's 16. If you come down, it's 16. This 16 you are seeing. If you tally this 1, these 4 ones, these last 4 ones here. So now, our next block size continue. You maintain your parent network, which is this. This is our parent network. We maintain it. Now we say 10.0.0.0.0. Our block size is 10.16, which is now our second octet. Our second octet, 16 plus 32, 16 plus 16, 32. Same thing, we maintain the same thing. Now you only need to know the ranges. Now you can know within this. You need to move 10.16. When you move it up, when you move it up now, it becomes what? 10.15 minus 1. 10.32, when you move it up now, it becomes 10.31. You see, you maintain the same thing. Plus 16 here will give us This 32 plus 16 will give you 48. 48 minus 1 is give you this 47. This is it. Now you try to know the ranges. Now the range is the first IP. Now we know this is our network. This is the network. Now with this network now, the first usable IP address is what? .1. You already know this. Now the last usable IP address here now is .14. On this network is .14. Can see this here. This is our last usable IP address, -1 here. This is a broadcast already. So the IP range, we already know the range 1 to what? Say 1 to 13, 14, which is our last usable IP address, 14.255.255. You see, we forgot about the first octet. Now the broadcast IP address now, we say what? This is our broadcast now is 15.255.255.255. We say 15, which is this is now our broadcast dot 255.255. Guys, please do the same thing. So now example 2 also, you only need to replicate the same stuff from this example 2. These are all the same thing, guys. Please. So let's just try to round up things. I'm kind of tired now. So now, this is the summary. Subnetting divides a large network into smaller subnets for efficiency of IP address management. Class A, B, and C addressing have different default subnet marks and ranges. Changing the subnet marks allow creating more subnets while reducing the number of hosts per subnet. Understanding how to calculate the numbers of subnets and hosts. So the assignment here, this is your assignment. How many subnets can you create if you subnet class B network? Which is this? This is the network 172.16.0.0/16 into /22. Basic question, I want you guys to do it. What is the range of the second subnet when subnetting a class C network, which is 192.168.2.0/24 to /27?